Alright, so in chapter 4, section 3, we're learning how to manipulate logarithms. So, a few problems in here. We're going to look at in WebAssign, and then I should have a supplement for this one. Find the exact value of the logarithmic expression. Well, again, this whole thing right here represents an exponent. Log base 4 of the third root of 4 equals an exponent. So 4 to what power equals the third root of 4? And this is just being able to recognize that this is just 4 to the 1/3. So whenever you have the cube root of 4, well, I think I can do that with the keyboard. So if we want to do a cube root of 4, it gives me that number. Well, that is equivalent to 4 raised to the 1/3, right? Because my exponent for the 4 is 1. So that's where these numbers are coming from. Whatever that exponent is for your base, that's your numerator, and whatever the root is your denominator. So 4 to the 1/3, if I'm doing log base 4 of 4 to the 1/3, then my answer would just be 1/3. And we could say that by, looking at this one, the natural log of the 4th root of e cubed. So that means this would be e to the 3/4. But recall that natural log is log base e. So I have e log base e of e to the 3/4 means it would be equal to 3/4. And so I'll just give an example of that on the supplement on why those are equal to each other. Also, they give us some rules in the text. There is a change of base rule on 221. And there are some properties of logarithms that we'll be using in this section. It's just how we manipulate logarithms. So the next one I want to look at is number 6. So this is expanding using these property of logs. If you see things that are multiplying with logs, it turns into addition. And the reason that works is because when you multiply like bases, what do you do with their exponents? Well, you add them. And again, this stands for an exponent. So when you multiply your like bases, you add the exponents. And again, these are just exponents. It's what they stand for. They're using a couple properties. They're using the product property here, and they're using the power property. So when you have log of your x squared here, with logarithms, you can pull that 2 out front to where it's actually a product. Think about when you have a base with an exponent raised to a power, like 3 squared raised to the 4th, right? So when you have something like this, this is equivalent to just 3 raised to the 2 times 4, 16. Those are equivalent numbers because you multiply your exponent and power. So with that power rule, that's why we would just multiply that 2 out front times our exponent. 2 times our exponent. Another one to look at is number 10. So here's where instead of expanding, we are condensing. Right? So we'll see that, well, if it's a sum, that means it used to be a product. Z times z plus 9 has an 8 on the outside, so that means it was raised to the 8th power. And when you subtract, that's dividing. That's your quotient property. So it's just manipulating those. And then evaluate the logarithm using the change of base formula. So there is a change of base formula that's talked about on page 221. But this is kind of an outdated thing. Most of the time, if you are figuring out a formula like log base 3 of 0.019, technology will do that now for you. Log base 3 of 0.309. if that was the right numbers or not. Or not at all, 0.019. Right, and so we can get these answers. We don't need a change of base formula, but the change of base formula says it's just log of whatever you you want it to be. So I'm going to say base 10 and not type anything. 0.019. And if I divide all of that by log base 10 of 3, I get the same answer. So this is using your change of base formula, but with today's technology, you don't have to do that. It'll do base 3. Again, all of these are base 10, so we just have to have some common base when you're doing a change of base formula. And typically we choose bases that we know, like log base 10 or natural log. Either way you do this one, you still get the same answer. Alright, so I'll do a short supplement on a couple of the questions above to see how we can manipulate them. But that's chapter 3, section 3.